All right, there we go. So for the presentation, we will be screen sharing a slideshow. Rather than, I think there's a couple people who still want to be able to share their screen, but for the most part, we'll just have one slideshow presentation. Generally, once the presentation starts, I'll ask everyone to mute your microphones unless you are speaking. If you have any questions during the presentation, maybe throw them in the chat. At the end of each presentation, we'll have a little time for questions, so you can either unmute then and ask, or put them in chat, whichever your preference. Well, Jordan, you've been keeping an eye on the waiting room.
I have.
Because I was like, because I saw the number went up, and I was like, I didn't admit anyone, so Jordan's keeping on top of it.
Looks like we're up to 16.
All right. All right, I will share my screen. And we will get started. It's 5 after, so welcome. I imagine most people in here are familiar with Halifax Makerspace. But in case you're not, so we're a nonprofit group. We help out local makers, individuals, organizations, and groups do all kinds of making related things. So designing, making, repairing. If you've been keeping up, we currently don't have a physical space during the pandemic. Our lease ended at our location in Bedford. But some of the types of making that were involved in our space, sewing and fabric projects, leatherworking, electronics, 3D printing, CNC, and more traditional woodworking fabrication. So it's a place for people to come together to share tools, talent, technologies. Place you can teach your skills to others, like we're doing tonight, giving people a chance to show off their projects and their skills. Place to learn from others. So right now, as I mentioned, so we are without a physical space. With our lease renewal and the effects of the pandemic, it didn't really make sense to continue in there. We're hoping eventually, once things settle down outside of the pandemic, maybe within the next probably less than a year, we'll be exploring some options to get into a new physical space. So if you're interested in that, if you're not on our mailing list, halifaxmakerspace.org, there is a place on there you can sign up for the mailing list, and that'll keep you up to date on what's going on with us, including future events like virtual show and tells, or once restrictions lighten up, we'll probably look to doing in-person gatherings like we've done in the past. So maybe kind of hangouts at coffee shops or pubs to chat about projects. All right, so we're going to start our show and tell. And first up is Marcel Woodrow.
Evening all. This will be fairly quick, and hopefully I won't talk too quickly. My project I'm working on, one of the projects I'm working on, welcome to being a maker, is a weather cover for portable generators. The one in the picture there is not mine. That's a commercial one. That's what I'm trying to emulate. Portable electric generators, if anyone's been keeping track of what's happening with Nova Scotia Power and the storms every Friday this past month and a half. We lost power for about 6 hours, the first big storm in January there. I have actually 2 generators in my garage, but luckily when the power went out, it wasn't raining or snowing at that point in time, so I can just roll the generator outside. But But basically, you want to cover on your generator if possible. Keep the rain, the snow off of it while it's running. It is producing electricity. It is burning gasoline. Some people build small sheds or hard covers. They'll use, and I consider using one of those plastic, Rubbermaid kind of backyard tool things, about 3 feet high, 4 feet wide. Commercial covers, soft ones, like the one in the picture, those are available, but they're not cheap. They're around $260, probably approaching, by the time you pay taxes and shipping, probably approaching $300, which for what it is, and all the reviews I've read, which is they work really well, but everyone says they're really expensive for what you get. So I'm working on a DIY version, and it is indeed a work in progress. I figure by the time I'm done, materials, not including time, but I'm retired, I have the time. I'll have this thing on the generator and working for probably in the range of around $50 all up out of pocket. Next slide, please, Adam. And that's another commercial one, which is actually made by the same company as the one you just saw. Champion is the brand of my generator. If I want to color coordinate, I'll go with the yellow one. They cost the same price. It's just a different version of it. The pros of the soft color ones, the commercial ones, they're really well designed. They fit, they go on, relatively straightforward. They work. On that picture, you see where the word Champion is on the cover. That's actually a flap that can undo by Velcro, flip up, so you can actually fuel your generator without actually having to take the whole thing off. Now they fit well, they're adjustable, but the cons are, they are freaking expensive. Like I said, it'll cost you close to $300, and my generator only cost me $750, and I really don't want to spend almost half on a cover. And the plastic parts, if you look at the bottom, farthest left corner and the farthest right corner in that picture, it looks like a little kind of flag poking down. Everyone says that those are plastic. Some people have actually broken them, putting them onto their generators if they're cold, and suck to pay $300. Oh, they sell a repair kit, but the repair kit's like another $50 to $75 just for a couple of those parts. Next slide, please. Just a snapshot of my generator and my development so far. I'll show you, if you look at the left-hand picture, you see the generator. Those two white straps that go from the corners up and over and down, those are, I'm not even sure what they are, other than the fact that I bought those 3 years ago for use for supporting tomato plants in a hydroponic project that my oldest kid and I did at the time. She's moved to Montreal. I'm not going to do tomatoes anymore. I had the plastic lying around on hand. In the commercial one, they use like a flexible rod. Anyone who's, it's just like a small pop-up camping tent. The tent poles, that's what they normally are. I could have tried to track some down and find them and build them, but this isn't building it. I had these straps in the garage. Why not reuse them? And if you look at the very top, there's a little purpley, greeny thing at the very top holding the two to get together where they cross. That's just a little C-clamp that I 3D printed and it was sitting around here. I don't even remember what I bought it for at the time. I think for holding down a power bar, but I know I already had it, so that supports that. Those are just two slight different views. But that's as far as I got so far. My next steps will be putting fabric on it. Next slide, please, Adam. This is just a highlight of the majority of the development so far has been coming up with a 3D design, 3D printed corner brackets. You can see where the white bar comes down in. It just slides into that little slot on the right-hand side of it. It clamps around the frame of my generator, just like the commercial one. There's a 3D printed knob. It uses 1/4 inch, 20 1/4 inch hardware, which I had to buy out. I think it cost me $3 worth of bolts and nuts. And that's only because I couldn't find the ones in my basement. And I know damn well I've got some somewhere. And as you look at the left-hand picture, if you look to the right-hand side of that little bracket, there's kind of a little hook there. That's my plan is when I get around to producing a fabric cover for this, I'll probably connect the corners of the fabric, probably to that little corner hook there, just using bungee cord, something to provide it with a hook on it. And the one on the right is the same thing, just from the other side. It's multicolored because I was burning off some extra filament. The design was really easy. If you look at the left-hand picture and you look at where the knob is, just up from the knob to the right, there's like a round, this looks like a circle. All that is a 3D printed pivot pin that pops straight down. It's not even glued in, secured. It doesn't have to be. I can undo that knob, the big knob, take it right off and put it right onto that tube without having to stress it at all, which is one of the problems with the commercial one. It only goes so wide and it pops on, and that's where I've seen people complain where if it's the bracket's cold and they try to pop it onto their particular frame, they've actually broken it before they even got the damn thing on their generator. Next slide, please. Some of my design things. Going for the same general concept as a commercial one. You've seen the pictures. I've even downloaded the manuals. It's straightforward. The beauty of it is I can set it all up in my garage, roll the whole thing out into the weather. And I can even start the thing in the garage, but my garage is separate from the house. And I'd have to put the generator way back into the garage to keep it out of the weather. So I can set the whole thing up on my generator, start it up and roll it out for use. Plastic banding I talked about, that's from an earlier project, available at a local hardware store. And the 3D prints behind me, not a foot and a half behind me, tucked behind the curtain, is my 3D printer. So I went through 3 or 4 different iterations, and I can still change if I got to make that hook or something different. To do, as I said, it's a working project. I still have to come up with a prototype fabric cover. I'm going to start with cardboard. Then I'll pick up a cheap vinyl tarp for like $5 a Canadian Tire, lay it all out, cut and tape so it'll physically fit. And then I'll probably, only because I have one again, manufacture a cover out of flame-resistant welding blanket. It's not fireproof, but they're designed that if a sparker does catch it, it tends to melt and put the flame out as opposed to create a fireball on top of a gas tank on top of a generator. And I have to come up with a suitable method for holding the fabric down. Depends how fancy I want to be. I may just use 3D printed tarp / blanket clamps and a short bungee cord. I may put grommets on it. That's about the last thing I got to figure out. That's way down the road. Anyway, next slide. That's it. Any questions from anybody? Sounds pretty quiet.
Marcel, do you plan on putting the pattern for the 3D parts out for public consumption, or what? Or do you want to sell this? Maybe the Makerspace could sell it, you know, that kind of thing. Good questions. The 3D parts, I've posted the exact same photos that you just saw up on a Facebook page. Strangely enough, I could only find on Facebook a single page kind of dedicated to portable generators. And it's actually, the page is, what it's supposed to be for is actually using a portable generator or external generator to power an entire house. And I'm not doing that, but I did post those photos up and there were a lot of people that seemed quite interested in it. My plan is once I get it all up and running and done, I'll again update, but I'll post it. Things like that, I tend to just put out for people for free. If my logic is I put, you know, 6 hours, maybe 8 hours, probably not even that amount of time playing with the designs and 3D printing it. And yeah, the actual design work was probably 2, maybe 3 hours of my time. 3D printing, the rest of the time is actually print time. I don't think there'd be an interest enough to be able to make enough money on it to make it worth making it selling it for profit. But what I will do at the time is I will most likely post them up on Thingiverse. I don't like the other ones. All the other online ones like Cults and other ones, you actually have to register to be able to download stuff. Thingiverse actually, you have to register to put stuff up, that's fine. But if you don't have to register, don't have an account, you can still download stuff. And again, if I could raise money for it for the Makerspace, I would, but I'll be honest, I just can't picture there being enough of a demand because the 3D printing is the easy part. The hard part's actually going to be fabricating the overall cover and cutting it to size, stitching it and doing up the seams, which I do stitching. I'm a sewer as well. It's just wouldn't be worth it. By the time I was done, that would probably take me 30 hours by the time I do each one. And the cheap part's the easy part. That's the 3D printing part. So that I'll throw up for free if anyone actually wants it. Good question though. If someone came to me and said they really wanted one for their own, I'd kind of offer it to them as a kit You know, I can't do high grade testing. I can't do fireproof testing on it. I can't call for it, obtain a CSA rating for it. I don't mind putting it on my own generator out in the backyard. I'd hate to have someone else have a real fundamental problem with it. But again, the commercial ones are maybe a coated nylon. They're nothing more fancy. They're nothing more fancy than a really good tarp. Good question though, but I hadn't thought at that point.
After this weekend, I'm in the Woodbine Park in Beaverbank, and I'm very strongly leaning towards getting a generator.
If you're interested in a generator, look on Kijiji and on a marketplace. There are lots available, and a lot of people will have them. And especially when there's a big storm coming, they'll buy one and they might start it up, or at the end of the season, they'll sell it. But you can get very good, preciously seldom used. The very worst you might have to do is have it taken to someone who does small engines. Like if they, long story short is, if you go pick one up to buy it and they can show it running, then it's golden. If they can't get it, like I got 2 generators, a small little baby one that I bought for price $150 Canadian Tire 15 years ago. I've replaced the carburetor on it twice. Now, it's not hard to do. Matter of fact, I've put more into spare replacement carburetors than I think the actual generator cost me. But long story short is, if you're buying one for home power use, the 2 things I would suggest, if I was going to do it again, one, I would get a dual fuel, something that will run gasoline and propane. I've got a great big propane pig in my backyard for running my fireplace in the house. And the other thing is, if you possibly can, get one that's electric start. I really have to finagle with it to get it going. There's no effing way my wife would get it going on by herself if she needed it. It's kind of why I keep the little one. I could talk her over the phone to get the little one started if she needed to. There's no way I could talk her to get the big one. Now, of course, dual fuel and electric start are going to cost a little bit more. You still get one for under $1,000 at Costco that meets both of those. Matter of fact, it's a champion. I think it's a model up from mine. The third suggestion: be serious about how much you're going to power in your house. If you want enough electricity to run a couple of lights, keep your fridge going. If you got to run the blower, run your furnace, you really don't need like you could get by with something around probably less than 4,000, 3,000 watt one, a kilowatt one. But like, it's a lot of things. Depends how much you want to run at a given time. Like my house is electric heat. There's no way I can run the electric heat off of that generator. I might run one room, but I need it because I've got a sump pump that if it doesn't run, the basement floods. I've got a fireplace that's propane in my living room. I can run the power to that, and I keep the fridge going. So between the big 3 big concerns, I get the fridge running, sump pump running, and heat in the house. And I can do that in the little one, let alone the big one. And for what's worth,
Marcel, I think we'll
running along. Sorry, guys.
Thank you, Marcel.
No problem.
any final questions for Marcel before we hop over to another project? Okay. Back to screen sharing here. All right, Bill, you are up.
All right, do you hear me?
Yep.
Okay, good. So yeah, this is going to be pretty quick, I think. Middle of January, a volcano erupted, the biggest eruption in quite a while. And then shortly after, next couple of days anyway, there started to be reports coming in that I heard of people with home weather stations noticing the pressure pulse. So this is a satellite picture of the volcano shortly after eruption, and you can imagine there's a fairly good pressure surge coming out of there. That burst of pressure went over the entire globe, and people started noticing these, that they could see it. So I run a personal weather station. I wanted to see if I could see it on my data. So if you go to the next slide, I'll just quickly explain my research into that. So the eruption happened at a particular time. Roughly speaking, it's going to move at the speed of sound, this pressure wave. So it should have got here to Halifax area 11:42 on Saturday. I looked at the pressure coming from my sensor, and we happened to be going through one of those storms Marcel was talking about. And so the pressure was changing fairly rapidly over the January 15th, 5 a.m. to almost 48-hour period I'm looking at here. But there were a couple of little blips, so I was wondering if those were what they were, and if the timing was right. So I wrote a little script that I put out onto GitHub, so people can look at it and use it for their own purposes. And what it does is it takes the long range trend out of here and emphasizes these little blips and pieces. So this lower one shows that after I put it out and advertised it in the weather software I use website, a number of people got interested in it and helped me refine it a bit. And so the final one, you can see it's looking at that smooth curve and flattening that, taking the smooth variation out and showing these little blips. And then another fellow in Australia, there's two guys who helped me quite a bit. One was in San Francisco, one in Australia. Maybe it was a San Francisco guy, came up with the idea of putting these little bands where it comes from Tonga all the way around the world to Halifax. And then, but it also goes the other way, does the long trip. We're a little bit closer to Tonga one way than the other way. And so the reverse one arrives a little bit later and then goes around again. And maybe this is the second one. Unfortunately, because my weather station's homemade and I'm having some issues powering it, I had an outage right around when the second one came in. So I'm not really convinced that's the case, but it's cool. You know, I could convince myself this is really it. And I'm fairly sure the reverse one showed up. So the close trip actually had to go all the way across the North American continent to get to us. And so maybe when it hit the Rocky Mountains, it got smeared out or something or other. So I thought that was pretty exciting. On the next slide and the next few, I've got some from other people. So this is a fellow in Austria. So he would have got the pressure wave first, I think, coming headed east from Tonga across the Pacific to over China, I think, or maybe over top of the North Pole. I'd have to look at a globe to really tell. And this is showing an earlier version of my software that his pressure is dropping, whatever's going on with his weather, he's dropping slowly. But there's a big spike that shows up there. So that's kind of really confirmed us. Next one. This is, I think, one of the folks who helped me quite a bit. So now I've got his location put on here. And same thing, he's got a sort of a U-shaped change in pressure going on, but then this big spike in the middle. Next one, Adam. Utah found a bug in my software with the removal of the smooth curve. And so this guy showed the bug because it's not doing a really good job of matching the curve. And but you can still see something that looks a little bit abnormal there. The reverse on there. So it looks like speed of sound isn't accurate for what speed the thing's really traveling at. And then because of the bad curve fit, this other spike is sort of lost in this sharp change in his, some high pressure system moving in. Next. Richmond, Virginia, so fairly close to us, and same kind of thing. The initial one doesn't show up very well, but the reverse one really does. And then the second one shows up pretty good. So in my case, I had an outage right in there, and this didn't really look too real. But the reverse one is very similar to ours. So Richmond, Virginia is a day or two drive away from our area. So so I thought this was a nice collaboration, that I wasn't just, you could go all X-Files on this, say, well, every one of these is a UFO going across the sky or whatever. So anyway, I thought this was a nice confirmation that what I was looking at was real. The arrival times are slightly different because he's in a different place. Next, I think maybe that's it. Oh yeah, one more in Paris. So yeah, this would be similar to the Austria one, I guess. Same kind of thing. The Venetian one's really close for him. He's a little bit closer to exactly the opposite side of the world from Tonga, and so the initial and the reverse are close. And then the second is quite a ways later on, I guess. Exact opposite of Tonga is somewhere in the middle of the South Sub-Sahara part of Africa, and there's nothing, absolutely nothing out there, let alone personal weather stations. I think that's it. Is there one more, Adam? Or is that the last of my slides?
That is the last one.
Yeah, so it was a nice little topic. If you go back to the one with all this stuff on there, I do have a link to the script. I learned a bunch of stuff. I learned how to do graphs better, read out of databases better. This is all Python code. This doesn't have to be, pressure pulses coming from volcanic eruptions stored in the particular database stored here. It's the software that I'm showing there is a nice kind of general purpose thing to graph some data you've got that changes over the course of time. And then the link I've got down at the bottom there is the actual group that uses this WX weather station software. And we had quite a lively discussion. That's what the exact link is there, is the discussion about this. So it's kind of cool. Yeah, I could see using this to watch for other kind of worldwide events. So I learned a little bit more about science, a little bit more about software, and had a good time too. I got kind of obsessive about it, and I thought it was really interesting that you could see that so easily. It kind of reminded me of the Halifax explosion, right? That would have been a little more obvious, but same kind of thing. Peter's asking what kind of pressure sensor I have. This is a BME 280, I believe. Yeah. And so it's kind of well, I'm doing another talk right after this one with the later generation, the same kind of thing, and I'll show you how that works if I can we get it going. Any other questions? Yeah, who's this Sean? Yeah, I want to believe. It is kind of funny. Apparently, you can hear meteorites entering the upper atmosphere. So, if you recall, quite a few years ago, there was a big fireball or bolide, I think they're called, over somewhere in Russia, and that would have showed up for sure. But that was before I had my weather station going. Okay, that's it.
Thank you, Bill. Next on the list is Jordan.
Cool, very good. All right. My first slide is a little bit wordy, just words, no pictures. So everybody who knows me from the Makerspace is familiar with how I'm very 3D printing centric with my maker activities. And I create a lot of functional prints where there's objects that screw together or fit in a very functional way. Maybe it's a tight fit or a slide fit, or are pieces of work where I'll be embedding other materials or electronic circuits or what have you in the printed material in a very precise kind of way. And I also work with a number of different printers. So it's a very common problem when you're working with a number of different machines or a number of different materials that your models can't be made perfect for all of them. You're always going to have nuisance differences where if you print it on one printer, it'll jiggle versus the other printer, it will be a perfect fit. So in some modeling languages, there are ways to parametrically modify your models so that you can render them for different printers. But usually the way people approach the problem is to actually have different parts that are available for sort of specific connectors that you might try a couple until they work, and then go with the particular one that works for that mate. So what I'm doing is using a language and a tool called OpenSCAD to make a calibration approach where you print a piece off to test your functional fits, and then you use the results that you get from that physical piece that you've printed to record what your design constants have to be, so that that printer is going to give you the right fit every time after that. And by doing that once and calibrating a few specific design constants, that means that you can do the rest of your modeling in a way where you can use those design constants and know that you're going to have a perfect fit. Next slide, please. It's a little bit, it's an interesting type of project to try and show in a show and tell. I've got one here in real life too. But the way that this works is the frame of these objects, including the signage and the matrix sort of rows and columns nature of the object, that's part of a programmed framework. So every extra type of fit you want to calibrate, all that you have to do is write the geometry for the type of element. So this is relatively newly finished. So there's only two different types of examples on the table there. There's screw fittings, and there's also block fittings. But for these examples, across the row, there's variation in what the gap distance is between the threads of the screw and the threads of the female. So I can print one of any given one of these calibratrices off on each of the printers that I have, determine that design constant value once, and plug it back into a constants file that I can later use for my real models. Next slide, please. So this is just a rendering of, on the left is the OpenSCAD tool that this geometry is actually written in, rendering an example matrix that just shows what those elements are of the matrix. And on the right, it's just a Python window to illustrate how I'm writing Python driver software to reduce the number of touches and to make having a whole arsenal of these for different types of calibration very easy and reusable. So the actual library in OpenSCAD, it has the features to basically automatically resize this based on the sizes of the elements that you need to calibrate, picking a size that is not going to have any geometry interference, and will also let you spread things apart a little bit more if you needed to be mating a larger component with smaller matrix elements. It also has features like these signs allow you to use arbitrary text. Oh, where's my camera? There's my camera. This is just some example text. It's actually meaningless, but you can use arbitrary text so that you can self-document the pieces so that you can keep track of what the actual slicer was that you used and what the actual printer and materials were, or you could keep dates or you could keep references to like your version control software, for example. And in terms of what the Python engine does to drive it, is it just does a better job than OpenSCAD does of giving you sensible defaults, and it can use things like properties of your system, like current date and time, and like references to, if you're using version control software like Git, it can automatically pull metadata out of there to give you stronger traceability. And it can also use those patterns in other variables to create understandable output names that kind of tell you exactly what your files are designed to be printed on. Next slide, please. This is just another example. As I was writing the library, I wrote a couple of examples that are, they're not actually for calibrating other parts. They're just for illustrating how the library works to generate the geometry for you. So this is an example that's been rendered in OpenSCAD, and I just pulled it into Blender to give it a slightly different look. And the library also supports L matrices or two-dimensional matrices. If it were a little further along, I'd show a wider variety of them and how L matrices are more useful in some situations and 2D are more useful in others. But maybe I'll show that next update. So we can go for, I think, what will be the last slide. And yeah, in terms of what this drives next, anybody familiar with any of my 3D printing stuff has seen some examples of projects that I've put together. But essentially, I'm going back and I'm revamping my entire content library with this concept of just-in-time design calibration so that you can have portability on all of your work. I'm just in my room where I do have 3D printed stuff just in my life here, like this big shelf. You can double click on my picture if you want to see it larger. And my lamp here, my wall lamp. Those are all based on functional 3D prints combined with electronics or just used for structural elements. And so all of the time that I spent working on those projects, part of it was carefully organizing which files I was able to print on which printers. And it's a problem that hasn't been solved in a good universal way yet. So I figured I'd take a shot at that and make for a better content library of my 3D printing stuff. I think that's all that I have to show in the way of tonight's show and tell. Hopefully I'll have some good examples of content that I build with the engine for another upcoming show and tell. So yeah, that's my last slide, and I will take any questions.
I know who I'm going to go to for 3D printing help when I finally start 3D printing, which I hope to be soon. That's really cool. Really enjoyed that.
Well, I always have a few minutes.
Sean just posted a question in chat. Are you publishing your code?
Yes, this will actually be the first thing that I polish up and release open source. And I'm probably going to have the OpenSCAD library up in the next maybe 2 months. I'm just going to host it on GitHub. And the Python engine that runs it is a little bit less mature, and I don't like to release things that are terrible because I'm a software professional, but I'll have that along a little while after.
And Peter Frank had a question. Do you anticipate being able to deliver calibration files for different brands of printers?
Yep, I do anticipate being able to deliver calibration files for different brands of printers. And I think that the organization and how to name the files so that they will be intuitive and will explain what printer in what context you want to use them for is going to be one of the biggest challenges, because not only would you have slightly different design constant calibrations for different printers, you'd have them for different slicer printer combinations and slicer printer material combinations. So you really have to consider your entire production pipeline, everything after your design rendering, all the way from your slicer to your machine configuration to your material may have an impact on your design constant calibration. So depending on how precise you want to be and how perfect you want it to be, you may want to tune everything in, pull a calibration from GitHub that is near to your setup, and then maybe even tweak it a little bit further to make those constants even more perfect.
Peter had a follow-up question. Could you separate the elements and make them independent of one another?
Yes, the elements can be separated and made independent of one another. And in fact, this is a male-female concept where every calibratrix needs a female, but only some of them need a male, because sometimes you're mating 3D printed parts together, and other times you might be mating a screw that you have, an M3 screw with a 3D printed part, or a USB plug, or an IC of a well-known size. So this does support male and female parts. They both have labeling built in, rendering capabilities. And I'm also, for anybody interested in the computer sciencey side of it, I'm also making some of these renderings able to decouple all of the elements so that they can be rendered in parallel, dispatched as jobs, rendered in parallel, and re-imported from multiple STLs to one STL, because yeah, you can do that. It speeds up the rendering substantially.
And Bruce had a question. What's your printer of choice and material of choice?
Oh yeah, should be reading. I actually prefer PLA. PLA, a lot of, it's the easiest to work with, so a lot of people assume that it might not have really great qualities, but it is actually it's the strongest of the common filaments, but it has less sort of flexibility and durability. It's more brittle, but because it has that high stiffness, it's very good for functional pieces. I should have brought up a couple more of my radio control RC vehicles and things of that nature, but you can make very good gear systems and various functional parts with PLA. Although I've been wanting to get more into PETG, especially. I've got a couple of rolls of that I should get around to printing more stuff with. And my favorite printer, I think my favorite is my Prusa i3 Mark III, which is the same one that we have one of at the Makerspace. But I like a couple of them. I also have some old MakerBot Replicator 2s, which are really great workhorses they print almost twice as fast as the Prusa i3 Mark IIIs. And they actually tend to produce slightly stronger parts, I find, but their fine precision isn't quite as high. They have very good accuracy and repeatability and strength and speed, but the i3 Mark III comes out looking just a little bit more perfect and a little bit sleeker. But of course, I have a couple good budget printers too. Ender 3s are great bang for the buck.
All right, if there's no more questions, we'll jump into the next presentation, which is back to Bill with donated SoC and carrier boards.
Okay, I'm off mute, right?
You are.
Yep.
Yeah, okay, just sort of background, in the public maker, Halifax Makerspace Google group, a fellow came out of nowhere and said, I've got these things, do you want them? And I said yes, went over to his house, took 2 carloads to get them, but I brought them home. We had closed the doors of the makerspace, so I have them. I'm not sure what I'm going to do with them, but I will explain what they are and then we can work that out. One idea I have is to use them to start doing, I like teaching. I like advertising about, the real scientific rational world around us. Not making any political statement, that's just what I am. And so I'm going to talk about what these things are in a little bit more detail. Next. Next slide, please, Adam. Yeah, so I could go through all these descriptions. I think what I'm going to do though is if you just switch over to allow me to show, or I guess I asked to share first. If you stop sharing, I can share, I think, Adam. I'll just show you it, and then if you want to go through the details of what's on those slides, we've provided the link, I believe.
So I've stopped sharing. You should be able to share now.
Share this one. Okay, hopefully that's showing up now. And if I bring back this, so these are at the heart of them, it's actually let me start with this. So so this is my this is what we got, or what I have in my garage. It's a little plastic box with some stuff on the front. On the back, it's got the common electrical mounting kind of thing, so it kind of looks like a thermostat or some kind of little box you'd have on the side of your house that does something. Pop that open, and inside is a small embedded computer, very similar to a Raspberry Pi Zero, if you know those. It plugs onto a carrier board that is screwed to the case and has some things on it. So I've taken one apart here. I'll also put this one aside. The computer is like I said, it's somewhat like a Raspberry Pi Zero. It uses a SD card. Doesn't have one in there. Okay, this one here does. So it's got an SD card in there. That's the file system, and a Wi-Fi card, the circuit board, antenna, or this one is better than a Raspberry Pi Zero because you can put on an external antenna. So you pop this off, it'll use the internal one. I think to do it right, you have to go in there and switch between the two. Anyway, so it's got that external antenna. The specs are in the presentation. It's about a USB for power, or you can feed power in through these 40-pin general purpose IO connectors. On the carrier board, I took one of those out. The pins you plug the computer into, a very nice little switched power regulator. So you can feed this thing anywhere between 7 and I think about 35 volts. And it'll put out a nice 5-volt regulated to good precision at high efficiency voltage. So this screw terminal is where you hook up your DC, higher voltage DC, and out comes 5 volts, goes all over this board and back into the computer. A microphone so it can listen. Over on the other side, that's facing the front of the plastic box. Let me use something with a little better pointing ability here. There is a motion detector, so a proximity sensor kind of thing, a 3-color bright LED. This is a, let me see if pretend you can, it's focused. A photo transistor that gives you the ambient light. This little silver box here is the pressure sensor. So it's a BME 680, a little fancier version than what I had in my volcano detector. Pressure, temperature, humidity, and air quality is what this thing will provide. That's it. On this one, you can see I've glommed on some 4 wires, and this is the I2C bus, so you can add on more peripherals if you want. And then this blue wire down here are some analog to digital lines on the computer. In a way, I think they're used on the carrier board, and so I was trying to read voltages off here, and it wasn't working. So I believe those are already used by like the photo transistor or the microphone or some other part. And then last but not least is, I think the coolest part about these little carrier boards is this Panasonic Grid Eye is what it's called. It's an 8x8 pixel infrared camera. Essentially, it tells you the temperature. Its vision is in the data sheet for this device, but it's about a 30-degree angle line of sight, and so you can get an idea of the temperature. So I've been playing around with these a bunch. Like I said, I added I2C. This other one I was showing earlier, I broke out the USB, and I've added some USB ports to this one to see if I could, have it work with an external hard drive or mouse or keyboard or that sort of thing. The astute viewer will notice that there's no screen. How do you work with those things? You can't see what you're doing. Well, it's got a network connection, so you can get on the network. Well, how does it get on my network? I haven't told it my password. So that's where it gets a little bit tricky to get them going. What I found works well is a USB to serial connector. There's they call it the debug port. You temporarily hook this to your serial port here, and then the serial console. For the gray-haired people in the crowd, you may remember when you worked with a computer just with a text line, and you didn't have this graphical desktop kind of thing. That's basically how you work with those. So I thought I'd just show you that real quick. So if I go to my my normal computer, so this is a terminal on my computer. I can do things like list the files that are on this here screen, clear it. If I want to connect to one of these boxes, I've got one up in my attic just for fun. So I can do a secure shell connecting to it. And they're not the fastest things in the world, but they're pretty good for what they're doing. This one is running quite a few processes, and you may wonder what I'm doing here. Well, it's cryptic garbage. This is Linux, so it's a good way to brush up on your Linux. So it's running a web server. It's running the Apache web server. It's sharing its file system across to other computers on my network through Samba. So it looks like a Windows file system if I need it to. So if I go to that web server, so the attic eye is this is the web server here. I can bring up this web page, refresh it. I mean, it comes back pretty quick. I can do this, and it'll give me a prompt to go into the device and work through it in a web browser instead of through that little box I had before. I wrote a little script that uses the Grid Eye, which I think is sort of the cool part of this thing. So Here you can see 8 by 8 pixels up in my attic. It's currently ranging from -2 degrees to 3 degrees. The humidity is 42%. The pressure's 989. It's not moving. There's no volcanoes going off anywhere in the world. The temperature on the board, the temperature sensor on the board is pretty useless because it's hot because the board is, got a lot of components running away on it, and so the board is at 20 degrees C. The attic is at somewhere around 2 or 3. The air quality, this Q is I haven't spent a lot of time looking at it, but that's kind of useful too. I noticed it'll drop down to the high 80s, and that might just be dust in my attic. But 90, I haven't explored how to quantify that number. It's it's 100% is pure, perfectly high quality air, I guess. But I haven't explored it much beyond that. So yeah, I've had quite a lot of fun playing around with these. The company that makes them, Acme Systems in Italy, of all places, where the Arduino was invented. They build a number of them. This one is the Arietta. There's the specs, so you can go look at that webpage yourself. So yeah, I've had a lot of fun playing around with them. I have roughly 500. And I put them on eBay, so I'm going to try selling them. Probably give the money to the Makerspace if I sold them all, we could probably pay for the rent for a year. But it hasn't been a whole lot of takers. I don't think I've advertised it completely well. Local people. I'm willing to give them away, or a small donation for my time. I've upgraded the operating system a bit, and they're just cluttering up my garage right now. I'm willing to give them as many as you want. Some of you already have taken the ones that are interested in them. So yeah, some questions. Are the boards programmable? Yeah, it's a computer. I mean, you can go in there and I've written these scripts that are doing what I showed earlier. Let me go back to this one here. This is this is another one that's staring at me right in the face here. If I refresh, it'll start working with any luck. Of course, it's going to do the demo thing and not work, right? Let's see if I can get it working here. Okay, so I'm learning JavaScript and WebSockets and all kinds of stuff while I'm doing this too. Sean asked if it could see mice or rodents. So this is my hand getting close to it. If I pick it up and bring it close to it, I can see my head. If I go one way or the other, so that bright yellow square in the middle is my head. Raise up my arm, you can see my sweaty armpit. If I raise up my other arm, you can see my other sweaty armpit. I think it would, in a dark room, subject to the resolution of thing, I think it would see a warm body. Going back to what the purpose of these things were, they were intended to go on the wall of a house of someone with the needed extra care and monitor if they were moving around, making noise, warm bodies were moving back and forth in front of the camera, and if not, alert someone over the internet that maybe you should go check if so-and-so is okay. Other questions here. The air quality, I don't really know what they mean by air. I thought it was volatile organic compounds. So that's typically what these kind of air quality sensors are, but I'm not sure. In my attic, I'm thinking it's dust. I answered your question, I think, Marcel, what they're originally used for. Sean has an infested place he wants to put a couple into, so it's worth a try. Joel, I think they're about 1 watt. The GPIO programmatically, yeah, it's actually pretty easy. I've kept the original software that was on these more or less intact. I've removed a little bit that I thought might be proprietary, but most of the real fancy stuff the company is doing is out on a server somewhere. Joel, if you want 6, send me a message or contact me somehow, and we can make that happen. Okay, so Sean or Adam, if you want to jump forward, or I'll stop sharing. I think that's about what I wanted to show. That's kind of the flavor of them anyway. And if you want to share the screens, go forward a bit here. I can tell you, I can just sort of wrap up. So yeah, some technical information there about what I did with them. Just keep going forward, Sean, or Adam. Why do I keep calling you Sean? That's what's in them. It's not cheap. I kind of wonder how they thought they were going to make money at this. There's if you bought it off the shelf, just the components alone are $200, and then the whole thing. I have no idea what they were selling these for. They've changed their business model. They're going a different direction with the concept. So next, this is what I've been kind of doing. Did I miss anything? I've learned a whole bunch about System D, which I'm still not really a fan of, but I could not get it. I mean, this is Debian Linux, which is kind of the grandparent of many of the distributions out there. Ubuntu uses Debian under the hood. External antennas still baffle me how they work. I don't have all the equipment to really tune them right. Next. Oh, it can't build the kernel itself. You have to build the kernel. I tried building the kernel. It took about 20 hours and then died. I've got a collection of those broken carrier boards that are good for spare parts. They have run some of the normal kind of makery Python libraries to get it to work a lot easier. I should really make this board part of this Adafruit library. Basically, it defines the GPIO pins. That would make it a lot easier. So I've started working on that, but haven't made a lot of progress. Next. Demo, I did that. Next. So my plan is either through the library, or if we're going to do COVID forever, I might start doing them virtually and just get these to people's hands and use it to learn embedded Linux. Wow. Your simple little Raspberry Pi, by the time you have it so it's actually usable, you're going to be around $100. These are going to be a little bit cheaper. That USB serial thing is maybe $10. A power supply, you may have one laying around because the voltage regulator is very flexible. But I think for almost nothing we could get these around Halifax, and there's got to be people who know more about some of these things than I do, and if we collaborate, we could do kind of things. I put one up in the attic just for fun, kind of. Further to Sean's point, I did have raccoons once, so maybe I'll get an early detection of them next time. And one of my upcoming projects, to hope if I can get this weather station staying active all the time, is a seismometer. I had a quiet backyard, so I thought it would be a good project. They're talking about building an apartment complex basically in my backyard, so I might shelve that. But they're pretty good for just moving around the house. I think that's it. Nothing else, Sean or Adam?
Didn't see any other questions. That's the final slide.
Yeah, okay.
Sorry, I wanted to mention, it's interesting bringing up raccoons. I actually had an idea for working something like this for a raccoon detection system, because I've had multiple visitations long visitations from raccoons here at my mobile home. So yeah,
Yeah.
something to think about going forward.
Yeah, I think, well, you know, you've got the motion detector, the microphone, and that Grid Eye thing. And then the vendor themselves, Acme Systems, on their website, they've got a description of how to add a webcam. So I haven't tried that yet, but it's got USB ports, so it should, any USB based webcam, it should work with. If you wanted to do some kind of pattern recognition to, you know, see a raccoon versus some other creature, it's only, what is it, 400 megahertz. So it's, you know, it's not useless. Doug's going to show us a computer that's a little slower, I think, in a bit.
Little bit.
So you know, it's no slouch. I mean, this was cutting edge technology only 2 decades ago, or I don't know, when was 400 megahertz a good computer? I mean, these things are. I tried to add up all the computing power of I think there's 500 of them sitting in cardboard boxes out in my garage, and so, you know, a gamer Bitcoin miner level PC is still more powerful than all of them hooked together, but they'd only consume about 500 watts or so.
Very cool. Thanks.
Yeah, so if you're interested, get a hold of me or the Makerspace, and we'll see about getting them to you.
All right, if there's no further questions, we will, it's here. So Doug, you are up.
Final presentation of the evening, I believe.
No, I've got one right after you.
Oh, okay, cool. So as it says, Arduino-based SD card interface for the Commodore 64. And there it is. Not a lot to it. That red board isn't used at all. The reason it's there is that originally when I started wiring this up, I was planning on using the red board. But then there was a conflict between what was in my setup for connecting to the 64 port and one of the SD shield lines. So I decided, you know, go to the Mega, what's actually, of course, a Mega clone. Lots more digital lines, more flexibility. So next thing I actually want to do is to get it working on the red board. There it is. And you can see that's actually a Commodore 128. That's the top left corner of it. The leftmost port on a 64 or 128 is called the user port. It was traditionally used for modems and printers. These days, it's often unused because not a lot of people are using modems and printers. They're all connected to the internet and things like that. And I'll go more into that with the next slide. So next slide, please. Yeah, I wanted to give a shout out to the Nova Scotia Power Crews because I was planning to work on this over the weekend and the storm came and we got clobbered, but got power back Saturday night. Because of that, I was able to get as far as I was with this project. And they worked hard, and there were trees on my wires, which they got right away Saturday morning. So thank you, gentlemen and ladies. Okay, so yes, as it says there, Commodore 64 and 128, the 1541 drive was famously slow. I believe there was an issue with the code with interfering with the interrupt for the video display. And so the actual in the 60 hertz cycle for the video refresh, a good chunk of that you couldn't use the drive because it would conflict with the video updates, et cetera, et cetera. It was very, very slow. Typical game, could take 2 minutes to load. And there was a joke, get a coffee while your game's loading. Later on, Epic's fast load and some other similar cartridges came out. And sorry, I was just trying to get my, oh, sorry, see myself on video there. Sorry for that delay, getting back to the presentation. Fast loader cartridges came out, that really helped. Fast load was multiplied your speed 5 times, the later ones were up to 10 times. So for the typical gamer, that was good. However, for non-typical users, I being one of them, even with fast loaders, the 1541, which by the way is a standard 5.25 inch floppy that was ubiquitous then, it wasn't a practical solution for games and applications that required multiple diskettes and or heavy disk usage. Wizardry series, in particular, the Wizardry 5, which spanned 5 sides of a diskette, and the C compiler that I use, Spinnaker Power C, the amount of disk swapping, the speed, it was just ridiculous. And like I said, it was pretty much unusable. And I was wishing, is there some way I could get a fast drive, some different setup? And then came, next slide, please, this godsend called the Creative Micro Designs, or CMD, RAM Link. As slow as the 1541 was, this was fast. Battery back RAM drive, and as it says there, use old style 30-pin SIM cards. It says here 2 minutes on a stock 1541, only took 2 seconds on a RAM Link. That's a bit of an exaggeration, but 7 or 8 seconds, certainly a lot of these operations could be done on a RAM Link. And I believe it's up to 16 megabytes of storage. That's a lot of 1541 disks. And you can set up multiple partitions, which are essence individual 1541 drives. So you can have the equivalent of 32 separate 1541 drives connected at once to your system. So it was lovely. The huge difference in the Wizardry games and Power C. Especially the Power C, it's like night and day. What would take 2 to 3 minutes could be done in 30 to 40 seconds. So yeah, and no disk swapping, which was great. So next slide, please. There was a little problem, is that to get a lot of data on a big drive, you kind of need either a really good network connection or another big drive with a fast connection. So bit of a problem there. Now, if you were only using a few of these 1541 partitions, there was a utility called mcopy with the fast loader that could get you by. One partition, which is one side of a disk, of a 5.25 inch disk, which is about 170 kilobytes, would go over in 53 seconds. So that'll get, remember, that's a fast layer. That's 7 to 8 times standard speed of a 1541. So you know how slow the stock 1541 is from that. So as I said here, if you had 1 or 2 1541 partitions, not so bad. I currently have 25 on mine now. So this solution really isn't very good. So next slide, please. Time went on. I kept all my old computer gear and my RAM drive. From time to time, would dig it out. And also Google. And new devices came up. One of the first ones was an IDE, or I guess ATA, hard drive interface, and related to that, compact flash interfaces. And most recently, there have been several individuals and small companies selling SD card interfaces. The very latest versions of these are generally implementing these super cartridges that are fast loader cartridges and a snapshot cartridge. I have a snapshot cartridge installed in my RAM link in my original picture, which are very common also back in the 80s. And an ML monitor and music players and graphic utilities and all sorts of things. There's one that came out in the last couple of years. I believe it's called a backbit. And it seems as powerful as an old Mac computer to me, but anyhow, good for people that want to have a lot of games. But again, I'm not sure if it's exactly what I need for what I'm doing. The RAM link is still considered the Cadillac of all storage devices for the Commodore 64, very flexible. So moving on to the next slide. For that reason, I still love my RAM link, and I'm in the Makerspace, and I've been thinking for a while, you know, there's Arduinos, it has an SD card interface on it. Shouldn't be that hard to set something up simple to load the RAM link from an SD card. So I read up on the library, bought an SD module, $10 to $20, I think. There's someone, fortunately, just released basically a circuit board for plugging in the 64 user port with a nice dual inline connector, which you can see in the original photo. Got that. And all I need then was to hook up some wires and write short 6510 machine language driver. That's the 64 processor, the 6510, and some Arduino C code. And the wires you connected there on the original photo would be the wires to connect to the SD interface, and then for the user port connection, 4 data lines and 4 handshaking lines, 2 in each direction. Next slide, please. So here you can see some photos of the whole setup. The first photo on the left, bottom left of the screen, Commodore 128 with the Arduino and the interface connector. On the screen, that is actually the Spinnaker Power C system that I mentioned before. I wrote basically a booter program to invoke the 6510 ML code and print its progress. And you can see plugged in the right side, the RAM link. The black cartridge sticking up vertically is called a Super Snapshot cartridge, which, by the way, was written by a gentleman from Sackville, New Brunswick. He made a lot of money on that. And the company was called Marshview Software. My sister lives on Marshview Drive in Sackville. I wonder if he also lived there and hence named it after. I never found that out. Named it after the street. And just to finish off the story about that company, on that cartridge is a digital sound, basically library / monitor, written by a gentleman named George Taylor. George Taylor replaced me on my first job, computer science, out of university. So there you go, small world. On the right, the drive on the top is a clone of CMD's classic hard drive, which was a complement to the RAM link. There's actually a special parallel interface on the back of the RAM link specifically for connecting to that type of hard drive. The bottom drive is a more conventional Commodore 1571, which has a plain 1541 mode and also a double-sided mode, which is the 1571 mode. And that's LMS. That M stands for Marshview there, Marcel LeBlanc. And that's just a quick and dirty way for me to enter the machine code. So that's the actual machine code that runs to do the data transmission. Next screen. Got it working at 11 a.m. this morning. So there's a listing of the disk that was transferred from the SD card through the interface onto a Ramlink partition. And there is Activision Space Shuttle running on the right. Very nice to see that screen. Next screen, please. Next slide. So this was an important consideration. Is it fast? So some traditional methods used to get data onto a Ramlink I've listed here to compare to mine. The classic way, 1541 drive, mcopy utility, 53 seconds for one side, that's 170 kilobytes or 171, one side of one floppy diskette. That clone of the CMD hard drive is called a Thunder drive. It's a SCSI drive inside, by the way, using the same mcopy, and I emphasize for comparison, using that special custom-made parallel interface for it, 18 seconds. So substantial improvement. If you just want to clone Ramlink partition to another partition, 10 seconds. So that's the, as you expect, the fastest possible way to copy a disk. My interface was 37 seconds. And I was very pleased with that because looking back at what I bolded the Ramlink parallel interface, that was custom designed by the world experts in the Commodore 64 hardware to get maximum speed going either to the Ramlink or to the C64 memory. So I've just, in something I threw together quickly during a power outage, I've got 50% of that speed. So I'm quite pleased with that. Next slide, please. Thank you, Jordan. So to do, again, just got it working at 11 a.m. this morning and just in one direction, which is SD card to Ramlink. I need to update the driver so it can also go in the opposite direction, Ramlink to SD card. You know, make it nice and makerspacey with maybe a 3D printed enclosure, LED lights, use an LCD alphanumeric on it, make it nice and fancy. And from what I've seen, it would be practical and maybe useful to do, although it certainly takes some research, to write a 64 device driver similar to what CMD did for their Ramlink hardware, which would make the SD interface a full standalone disk device that you would access exactly like you would a standard 1541 with the load, save, and directory commands and all that good stuff. But at the bottom, my ultimate goal is to create a modified interface and connect it to, drumroll please, next slide. There's the holy grail of early home computing. And there's the hint, and you probably couldn't see it, but this is the other hint that I'm wearing. This is the Intellivision Classic Running Man that we use in football and other games. And this guy's the dealer from Poker and Blackjack, which is the pack-in game originally for Intellivision. And this is one of the rarest, well, computers in general in the world. When Intellivision was first marketed, its whole major sales point was that it was a real device, a real state-of-the-art electronic system, unlike the Atari, and you could actually turn it into a computer. And there's the computer module. There's a little bay that the actual Intellivision game system that you might be more familiar with connects to, and connects to the cartridge port through a ribbon cable. I was very excited when I saw this, when I got my television back in 1980, and never made it to public sale outside of a limited area in California because it was very expensive, something like $700 in 1980 money. This tape drive was a special combined audio and digital tape drive, notoriously unreliable. Mattel realized that this was not going to work, so they silently pushed it aside. And eventually he got fined by the Federal Trade Commission for false advertising. And then very quickly shipped out a cheaper version of this called the, at least the Intellivision just computer system. Well, I have one of those as well. I actually have, this isn't mine, but I have a keyboard component. I'm only personally aware of about 10 in the whole world. There have been estimates that 50 intact ones remain. Some were sold to a surplus unit. Some of them were converted to development systems for the Intellivision game developers, and some of them kept them. That's the only reason they're around at all. So very rare. It's got 2 ports in the back. I think they're both, at least one's a printer port, which would mean like a parallel port. So with a little digging, I should be able to hook up my system to it. And that is it. I'm going to take a quick look at the chat here. Okay, Bruce Lee, yeah. I couldn't get that running. I actually wanted to do that for the screenshot, but there was some incompatibility with the RAM link. C64 code, public domain. Officially, no, but a lot of the companies aren't around anymore, so lots of disk images out there. With tape drive, yeah, and the back in the day, the ColecoVision computer, which was the same idea called an Atom, also had a digital tape drive and met a similar fate. You know, it's like your old audio tapes would get chewed up in your Walkman and they'd get chewed up doing this as well. So, yeah. Now, some of the things like the Commodore 64 had what's called a data set, and TI-99 and Atari, those were actually basically standard audio cassette players, and there was a to D interface. So the program was actually encoded in audio frequency signal. The data drives were a bit different. Data drives were supposed to be more sophisticated. So yeah. Yeah. Okay, that's the last comment I saw.
Any remaining questions for Doug? All right, thank you very much, Doug. All right, we are running a little over time. We generally try and keep these to an hour and a half. I will run through mine very, very quickly, and then we will finish up. So I recently had a solution, or had a problem that needed solving. I'm a member of a modular model railroad group, and we wanted to put in a grade crossing across 3 tracks. And I've got lots of experience with Arduino. Actually, I'm gonna do these slides out of order. So I've done under track sensors before, just an IR sensor hooked up to an Arduino. But to do this properly, you would want sensors on either side of the grade crossing a ways out, so that when a train approaches, it registers it and it can put down the crossing in time. One at the middle of the crossing, so that when it clears, it can start to raise the arms and turn off the lights. And then in the other direction, because you've got trains coming in both directions to be able to sense that. So with 3 tracks, it was going to be trying to deal with 9 sensors, which felt a little bit, just a little bit too much. So I thought about maybe looking at something different. So this is a photo of the sensor, VNCL 4040 proximity sensor. And then many of you, if you follow kind of Raspberry Pi and Arduino and microcontroller stuff, might know that Raspberry Pi put out their own microcontroller recently, the Pico, which is an RP2040 chip. A lot of other manufacturers have put out their own version now. So this is an Adafruit QT Pi. So I won't stay on these long, but you have the link to the presentation. So if you want to find any of the details about these components, they are in here. So all I needed to get prototyping with this was the QT Pi, the proximity and lux sensor, the JST SH 4-pin cable, which is normally referred to as a QT or a quick cable, and then just a USB power bank to power it. Yeah, so this was going to involve 9 pins for sensors, 2 for servos, 2 for lights. And so the prototype that I threw together, and having the components with those wired connectors, just being able to run a cable between them, not having to solder anything, was super handy for just trying to proof of concept this. So in the top left there, there's a green light showing. And the nice thing about this QT Pi board is it has an integrated LED, but it's actually a NeoPixel. So you have full RGB control, which is great for using as kind of a troubleshooting, debugging light. So there's 3 tracks there. When there's nothing present, it is green. I still have to do some calibration in terms of the positioning, but I took just a piece of cardboard there to position, and at what is the furthest out turns yellow. The next track will turn blue, and then the final track will turn red. So it's measuring the distance to whatever is blocking the path. So I'll definitely need to do some calibration once I have this properly mounted and try it with different railroad cars. But so far, if you want to learn more about kind of the QT/quick, normally I had just done components like hooking up with on breadboards, soldering wires. This just made things so easy. Sometimes costs a little more, sometimes doesn't. So getting breakout boards like that can be handy for prototyping. So this is the Pico from Raspberry Pi, and the chip, the RP2040 is what the QT Pi is based off of. Yeah, you can get a Pico for $6 Canadian at Elmwood Electronics. Maybe cheaper at other locations, but that was just the one I tried. For programming, MicroPython, CircuitPython, C, and Rust. I believe I used CircuitPython in this. Proximity sensor. I just randomly looked for one to try and proof of concept this. So this is the one I stumbled on. This one ranges from about 0 to 200 millimeters, which fit my purposes. I'm still trying to figure out, it's a little sketchy on the furthest track out. So I'm still playing around to see if it's going to suit this particular project. I don't really need the ambient light sensor, but it does have that as well. The thing I did find out, I bought 3 of them hoping that I could put all 3 communicating via I2C, but they have, each one has the same address. So I would need multiple I2C buses to do this. Although potentially if I use the chip to power cycle one at a time, I might be able to just get the readings, but not all 3 at once, just cycle through, and with the timing, that might be enough. Might be fast enough for me to do it. Yeah, so that was the last of my mine. So yeah, I have my prototype. Uncertain if it'll do the trick, but I'm going to keep exploring. So thanks everyone for coming out. We will this got a good number of people out. So oh, I actually didn't ask if anyone has any questions about my my project. I know that was pretty brief, but Yeah, if there's no questions, if you have any general questions about the evening or about the Makerspace, feel free to throw them in chat or unmute yourself and ask. Check out our website to get signed up to our mailing list. I believe we have the details about our Google group, which is kind of a forum. So if you have maker-related questions, you know, whether it's anyone in town have this spare part or know where I can buy something or tips and tricks, that's a good place to go. And then our mailing list, we will have info when we do future events. So future virtual events, future in-person events when we are able. Stop sharing. So thanks for coming out. And just checking to see if there's any questions in chat. All right.
I'll stop the recording.